Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have a to the power of n plus 2 to the power of n equals to 130, and we will solve this problem for the real values of n. So here we find only real roots of this problem, or you can just say that our n belongs to R. So the very first thing we are going to do is, here first we will rewrite this equation as, here you have 8, and now we can find the prime factors of 8, and you know that the prime factors of 8 are 2 to the power of 3 and its whole power n, plus here you have 2 to the power of n equals to 130. And in the next step we will use here the nice exponential law, and you know about this law. If we have a to the power of m to the power of n, it is equals to a to the power of n to the power of m, and this whole equals to a to the power of m times of n. It means that if you can interchange these two exponents, then it cannot be affected our final answer. So now here we need to change these two exponents. So after changing these two exponents, we will get its output in the form of 2 to the power of n and its whole cubed plus 2 to the power of n, and this whole equals to 130. And in the next step we will make here little bit simplifications or little bit substitutions here in order to convert this exponential equation into the cubic form, so that here we will just take y equals to 2 to the power of n. So when you put y equals 2 to the power of n, then this equation will becomes in the form of y cubed plus y equals to 130. And in the next step you will see here it will becomes in cubic form, so that now we will make the factors of this equation, or you can just break its middle term and we will easily get the factors of this equation. So we write y cubed, and here you have plus y, and we will write it as minus 25y and plus 26y, because when you subtract minus 25 plus 26, then you will easily get plus y, and we move this 130 in the left hand side and you get minus 130 equals to 0. So now here we make the factors of this equation by no efforts. So here you can just take common y here, and you will obtain y squared minus 25, and here you take common 26, and you will get here y minus 25, and this whole equation equals to 0. So in the next step we will make a little bit simplifications here, and we will rewrite this expression as y times of y squared minus 25, and we will write it as 5 squared, and plus you have 26 times of y minus 25, and this whole equation equals to 0. So here we need to use the nice square identity, and you know about this identity. If we have a squared minus b squared, it is equals to a minus b times of a plus b. So we use this identity here, and we will again rewrite our above equation as y times of y minus 5 into y plus 5, and here you have plus 26 into here you have y minus y minus 5. Here we make a little mistake, because when you take common 26 here, then you will get only 5, so this term be the only 5. So now this whole equals to 0, and now we will take common y minus 5 on each of the term, and you will get here y minus 5 times of y into y plus 5. Here you just remaining that y into y plus 5, and here after taking common y minus 5 you get 26, and this whole equation equals to 0. And in the next step we will make a little bit simplifications, and you will get y minus 5 times of, we multiply this 5 on both of the terms, and you get y squared plus 5y plus 26, and this whole equation equals to 0. So you see here we have two cases here, so we divide this expression into two cases. So our first case is we write y minus 5 equal to 0, and the other case is we write y squared plus 5y plus 26 equals to 0. So in this case you will get the value of y is 5, and in this case, now first we will check is this equation will gives us the real root or not, by using the discriminant formula. So that here we write the coefficient of this equation, and you get a equals to 1, and b equals to 5, and c equals to 26. And the discriminant formula will be looks like in this form: delta equals to b squared minus 4 times of ac. So now you will just put the values of a, b and c here, and you check the behavior of this delta, so that you will get here 5 squared minus 4 times of a is 1 and c is 26, so that you will get 5 square will becomes 25, and 4 times of 26 will becomes 104. And now you subtract these two values. 25 minus 104 will be equals to minus 79. So it is less than 0, and our discriminant tells us that if you have the value of this delta is less than 0, then it gives the no real root. So if it gives no real roots, then we will reject it this case, and we can just proceed here this case only, because in this problem we need to find the real roots only. So now we will in the start of the problem we will take our y equals to 2 to the power of n. You will see here this is y, the value of y, which is y equals 2 to the power of n, and now we back substitute the value of y here, and you get 2 to the power of n equals to 5. So in order to find the value of n, here we need to take the log on both of the sides, and you will get its output in this form. And now we use the property of logarithm in order to find the value of n. So we move this n in the front of this log, so you get n times of log 2 equals to log 5. And now we move this log 2 in the right hand side, and you will get here n equals to log of 5 over log 2. And now you will use the logarithm table or the calculator in order to find the value of the log 5 and log 2, so that the value of log 5 will be 0.69 and 89 over the value of log 2 is 0.3010. So finally you will divide these two values, and you will get the value of n equals to 2.3219. So this is the our final value of this problem. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.